students. Today we are going to study empirical and molecular formula. Now we already know the formula of the different compounds. Like carbon dioxide, we have the CO2, ammonia, we have NH3, then methane, we have CH4. So these formula that we already know. Now where have these formula come from? So exactly, first the empirical formula was being formulated and then the molecular formula. Okay. Now which, like suppose if we have the carbon dioxide or ammonia, so these formulas that were being made. Now here we can see it is 1 atom of carbon, 2 atom of oxygen. So the ratio we can take it as 1:2. Here we have 1 atom, 1 is the ratio, 1:3. So this is actually the exact ratio of the atoms, but the empirical formula is the simplest whole number ratio. That is the simplest ratio. Like suppose if we have benzene, we are talking about C6H6. Now here we can see 6 atom of carbon and 6 atom of hydrogen. Okay, that we already know. That is the benzene ring. Okay, this benzene ring, we have all the 6 carbon atoms are there, 1, 2, 3, 4, 5, 6, and everywhere we have a hydrogen along with this. Okay, now generally the electrons are resonating or they are circling, that's why we put like this, and they are alternative double bonds over here. Now first is, so what we are studying, C6H6, that is the benzene. Now here the ratio between the carbon, 6 atoms of carbon and 6 atoms of hydrogen. The ratio is 1:1. Okay. So for all the 6 atoms, there is 1 hydrogen atom. So ratio is 1:1. So we can also write the empirical formula for the benzene is CH. That is 1:1. C and H. Okay. Now, so the empirical formula is the simplest ratio. It is not the exact ratio. The exact ratio, the exact molecular formula is this. But the simplest formula is this. Okay. Now we have the acetic acid, CH3COOH. This is also known as the acetic acid or the ethanoic acid. Now here we can see we have 2 atoms of carbon, we have 4 atoms of hydrogen, C2H4 and O2. So what is the ratio, empirical formula ratio we can see? We see that the carbon and the oxygen are 2:2, whereas the hydrogen is double of them. So it will be the 1:2:1. Okay. So the empirical formula will be what? CH2O. It will be 1 carbon, 2 hydrogen and 1 oxygen. So the simplest ratio is called the empirical, whereas the molecular formula is the exact, that is the actual formula which is there. So for that we have to study now the empirical and molecular formula. Now let's take a pause. So the empirical formula is the chemical formula which expresses the simplest whole number ratio of the atoms of the various elements present in one molecule of the compound. So that is the empirical formula which will tell you the simplest whole number ratio. Whereas the molecular formula is going to tell you the exact, that is the true formula of the molecule. It expresses the actual number of atoms of the various elements present in one molecule of the compound. So it will tell you the exact number, that there are 6 atoms of carbon and 6 atoms of hydrogen present in one molecule of benzene. So the molecular formula will be this, but this will tell you the simplest whole number ratio of the various atoms which are present in that compound. Now what is the relation between the empirical and the molecular formula? So the molecular formula, if we have to get it, will be N into empirical formula. So we have molecular formula is equal to N into empirical formula. Now this N can be 1, 2, 3, whatever. Now suppose if we are talking about hydrogen peroxide, H2O2. Okay. Now we already know H2, water is this, H2O. Okay, where the hydrogen 2 atoms and oxygen 1. This is the exact formula for the water, but this is the exact formula for the, or the molecular formula for the hydrogen peroxide. Now basically, what is the empirical formula? It will be the simplest ratio. So here the hydrogen oxygen are similar, so H and O it will be. H and O. Now that is the one atom of hydrogen. It may be similar. We can write HO, we can also write, but this is the empirical formula. Empirical is the simple, so it may be H3. When we write HO as the empirical formula, it can mean either 2, it can mean either 3, H3O3, H4O4, because the same number of atoms they both have in the molecule, okay, hydrogen peroxide. So then when it was being found out, so like HO, it was the thing. Now empirical, from the empirical formula, what will be the empirical formula? Mass. If you have to find out empirical formula mass, so it will be HO. H will be 1 and then O will be 16. So together they become 17. So this will be 17. Okay. But later on, when the atomic mass, the mass of this compound was being done, then it came out to be 34 grams. So what does that mean? We find out as 70, but it was actually 34. So then the exact formula, this was the formula which was predicted before finding out the atomic mass of the hydrogen peroxide. And when it was came 34, then it was being multiplied by 2, that is 17 into 2. So then the molecular formula came out, that will be 2 into 17. So that became 34, which exactly came. So this is how. So then this formula was being found out that in order to calculate molecular formula, we have to multiply this n by the number, that is the 2. This side 2. Now it may be 0, it may be 1, 2, 3, it may be any values. We can multiply and we can get the molecular formula. Now HO, so here we have to multiply 2. Now for the compounds like acetic acid, I told you, CH3COOH, where we have C2H4O2. Okay, what was the compound? CH2O is the empirical formula here, because we have done this. Now relation between the empirical and molecular formula. So molecular formula is n into empirical formula, where n is any integer such as 1, 2, 3. N will be this, n we can find it as molecular mass upon empirical formula mass. Now molecular mass is generally being given, it's experimental wise, and the empirical formula which we will calculate it out, and then we are going to add all the atomic masses of the elements and we are going to get the empirical formula mass. Okay, like empirical formula mass here, so it will be C12, then H will be 2, oxygen will be 16. So this will be how much? 14, 16, 30. So the empirical formula mass for the acetic acid, if you are going to take it out, it will be CH2O and it will be 30. So empirical formula, whatever, like here HO, 17 is the empirical formula mass. So first we have to calculate it out, the empirical formula mass, and then we can calculate the molecular formula. This empirical formula mass we have calculated it out and then multiplied by n, and then you will get the molecular formula. Now first we have to get the steps, how we are going to calculate the empirical formula. So if two things we have to know, and then we can calculate the empirical formula. First is percentage composition of different element by mass. We will be provided in the numerical what is the percentage composition of the different elements. From them, and the atomic masses will already be given, or you should be knowing, and then we will be calculating out the empirical formula first. Then from the empirical formula we will calculate the empirical formula mass. From the empirical formula mass we will be calculating out the molecular formula. So the first step for calculating out the empirical formula, these are the different steps. So first is to convert the mass percent into grams. Mass percent into grams. So whatever percent will be given in the numerical, suppose carbon, hydrogen, oxygen, so that mass percent will be converting into grams. Second is to calculate the number of moles. So whatever percentage we are being given, that mass upon the atomic mass, from that we are going to calculate it out the number of moles of that element. Then third step is we have to calculate simplest molar ratio. Then last is the simplest whole number ratio. We'll be doing this and you'll be able to understand. And then last step is to write out the empirical formula. And after we have written, first we'll convert the mass percent into grams, then we'll calculate, divide it with the atomic mass, find the number of moles, then we'll calculate simplest ratio, and then simplest whole number ratio, then the empirical formula. After the molecular empirical formula, we'll be calculating out the molecular formula. So let's see the very first numerical that we'll do. Focus it on. A compound has 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. This is all the compound have. Its molar mass has 98.96 gram. So even the molar mass is being given to you. What are the empirical and molecular formula? So we have to calculate the empirical and molecular. So this is the table, or this is how the tabulation has been done. Okay, so first given, whatever in the numerical is being given, first we have to write that and then we have to calculate the empirical formula. So step wise we have to keep doing. Step 1 is the calculation of empirical formula. So what is given in the numerical? A compound has 4.07% hydrogen. So first we are going to write, the first column is made of the elements. Whichever elements are present here, carbon, hydrogen and chlorine are present. Second is symbol. Carbon is the element, symbol C, hydrogen H, chlorine Cl. Third column is percentage. So whatever percent are being given, we are writing this. Carbon 24.27, hydrogen 4.07, chlorine 71.65. Next column is given for the atomic mass. Now carbon atomic mass is 12, hydrogen 1, chlorine 35.5. Then next is, that is the stepwise as we have seen, that we have to first write element, symbol, then percent, then atomic mass. Then we are going to divide whatever percent we have got by the atomic mass. And why are we doing this? Because we need the number of moles of element. Because from that moles we will take out the molar ratio, simplest molar ratio, whichever number is the least over here, the smallest, that has to be divided with all the three. Okay, so here we have divided the percentage 24.27 by 12 atomic mass. Here also we have divided the percent by atomic mass. Here also we have divided by atomic mass. Now simplest is 2.02. Both of them are having 2.02. This divided by all of them we have divided. So we get 1 over here. Here also 1, and this side we have 2. Now these are all whole number ratios, so we don't need to do anything. Otherwise, if they are in points, then we have to actually multiply with the suitable number so that they can be a whole number. So this whole number ratio is taken out whenever we are not getting it in whole numbers. Or if you are getting in 1.5, 1.3, then we have to multiply and make it double or triple. We have to multiply with a common factor. Then this is how we get the empirical formula. Like suppose if we get carbon 1, so it will be C. C1 or C is same. Then hydrogen we are getting 2, so we are writing H2. Chlorine we are getting 1, so CH2Cl is the empirical formula that we get from this. Now calculation of empirical formula mass. Now we have got this empirical formula, we need to calculate its mass. So C is 12, H2, so H will be 2, because since there are 2 atoms of them, 2 into 1, plus chlorine is also 1, 35.5. So this all we are going to add it off, so it will become 49.5. Now step 3 is, after we have calculated the empirical formula, after we have calculated the empirical formula mass, third is we have to calculate the value of N. Now this N will be calculated by dividing the molecular mass by empirical formula mass. Now we are being given the molecular mass as 98.96. It's being given in the question. So this 98.96 upon which this formula which we have calculated 49.5 will give us 2. Now step 4, after we have calculated the N, we already know what is the formula, molecular formula. n into empirical formula. N we have got 2. So this 2 will be multiplied. Now empirical formula was CH2Cl. So 2 into CH2Cl, that is 2 of the carbon, hydrogen will be 4 now, chlorine will be 2. So this is the exact formula of the compound that we have to get. So this is the answer for the empirical and molecular. This is how we have to calculate all the other numericals. You will be given with the percentage and the molecular masses. You have to get the empirical and the molecular formula. So more you are going to solve, you have to make it column wise, and then you are going to form out first the empirical, then the molecular formula. So the more numericals you practice, the better you will be able to understand that how we are going to find out the empirical formula. Today's topic, empirical and molecular formula. So empirical is the simplest ratio, simplest whole number ratio of the atoms of the elements present in the compound, whereas the molecular formula is the real or the actual formula of the compound. Okay. Now for example, methane, if we are going to talk about, now methane, it is carbon is 1 ratio 4. This we have to get 4. Okay. So this is actually the molecular formula, that is in this will be the 4 times it will be present. Now molecular formula is always, how is it related to the empirical formula? Molecular formula is equal to n into empirical formula. So whatever empirical formula you get, you have to multiply by n to get the molecular formula. And how do you get this n? So molecular formula is n into empirical formula. And for this n you need molecular mass upon molecular formula mass upon empirical formula mass. Okay. And for this empirical formula mass, you need to have the empirical formula with you. So first, for the given steps, we'll calculate out the empirical formula. From the empirical formula, you will get the empirical formula mass. Then you're going to divide. Now this is generally given in the numerical. So you'll divide it by this and you'll get the n. You'll put the n over here and your empirical formula over here. So you'll be able to calculate out the molecular formula. And for the empirical formula, we have to actually make the columns like this. You'll get the element, then you will have the percentage, then you will divide your percentage by atomic mass. So we have percentage and we have the atomic masses. First column is element, then you have percent, then you have atomic mass, then you divide it and you get the molar ratio. And then you get the simplest. Here the molar ratio, here the simplest ratio. That is the least one. Suppose if you get 4.2, 1.2 and 3.8. So the 1.2 is the least one. Okay. So the simplest one, whichever is simplest, you will divide all the 3 by this. Suppose 1.2 you get, so you will divide 4.2 upon 1.2, 1.2 upon 1.2 and 3.8 upon 1.2. You will divide all the 3 with that simple, whichever is the least one. You will divide all the 3 by this, and whatever number you will get, if it is not in whole numbers, then you will multiply it in whole numbers, and if you get, suppose this is 4.2 and 1 by 2. So near about you will, suppose if you get here 3, you will get 4 here, suppose 1. So whatever elements you have taken, that will be the formula. C3, suppose if it's H4, it's O1, so it will be O. So whatever you get, that will, those elements you can guess. So this will be the empirical formula. By after you get from here, molar ratio, then simplest ratio, then whole number. If it's not in whole number, then you have to do. Otherwise, you'll just write the formula like this. And from this, you're going to calculate the empirical formula mass. C we know 12. So 12 into 3 is 36. Then 4 is 40. 4 into 1 is 4. Then O is 16. So it will be 40 plus 16. So it will be 56. So this is your empirical formula mass. Now this empirical formula mass, you will put it here. Whatever is the molecular mass given here, you will calculate out the N. And this N you will put it here and you will get in the empirical formula. So here suppose if you are getting 56 and molecular formula is also suppose 56 upon 56. So you will get 1. Okay. So N is 1. So what is the empirical formula? It was this C3H4O. Now 1 we are getting, so same. So that means molecular formula will be the same, C3H4O. So that you have to multiply whatever number. Here we are multiplying by 1 because here the N was 1. 56 upon 56, so 1. Suppose if it was 2, N is 2. So you will have 2. So 2 into empirical formula. So this will become 2 into. So C in 6 it will become. Then here CH8 and then O2. So whatever is the N, you have to multiply that time. So if it's 3, it's 4, whatever N you will get. So that will, and if it is 1, that means the molecule same empirical formula mass and the, so the empirical molecular formula are the same if it's N is equal to 1. So this is how we have to do, and I will give you in the assignment many of the numericals of this. So please try to calculate, and if there is any doubt, we'll talk.